So when we're flying or something, or well, not really flying, but when we experience high G accelerations, people can lose conscience or the brain may not work as well or cause long-term damage. Now, this is a problem for astronauts maybe in the future with rockets and or doing high G maneuvers. And it's kind of a reverse problem of having low gravity. Gravity in some ways, but another one is that it can also maybe that longer spent in low gravity, maybe the worse you can handle these short periods of high gravity. And it doesn't break bones or stuff like that. What it does is it causes a blood flow either to flow too much to your brain or too little. Another thing is that also low gravity does this naturally over time that not enough blood flows to certain body parts. It can also cause, if it's really quick, ruptures in blood vessels or increase your chances of having ruptures or strokes or something like that later on. And it can also cause gas bubbles to form in your blood, which can harm you, or not enough oxygen to reach your blood, or too much. And these gas bubbles can really be dangerous that form in your blood. So I want to talk about maybe an artificial way of fixing this in the future, beyond what we have now, which is G suits. And what G suits are this wonderful invention where you put in stuff, it compresses your body in certain ways, so the blood doesn't pool or flow too much in any one part of your body. And you can even sometimes have liquids to better adapt to different ways of movement and stuff than just static ones. And there's rumor that one of the liquids is actually beer for the best G suits with the manufacturer in German, because it's a goldenness liquid that is drinkable, and they won't tell you exactly what it is. But that's a rumor. And the high G, I also want to say the high G loss is called G lock. So my idea is to have an artificial organ that does two things placed near the brain. One is it pumps blood. Well, three things: pumps blood to the head when your heart has a hard time pumping blood, it's not pumping enough. Another thing is it pumps blood away to keep it if there's too much blood and keep the circulation going. But it also makes sure the blood is oxygenated, but also so the blood doesn't have too much any bubbles form in it, so it gets rid of that. And how do we do that? Well, I suppose having 4 circles, which I made here for the simplest one. And these circles are arranged so that they're kind of a square. There's one in the left top corner, there's one in the bottom, there's one in the left bottom, there's one in the right top and right bottom. So like a square. And one of them, 2 of the diagonals have blood going through them in opposite directions, and 2 of them have air going in them in opposite directions. And how it works is that they'll pump blood with a set series of pump blood to the brain and pump blood away. But there'll be a set of valves, and these valves will adjust to G acceleration suddenly or pressure suddenly to keep it balanced and act as an extra kind of heart. On the other hand, and this can also help in low gravity situations long term maybe, and it could also help for people with maybe heart problems or other conditions to pump blood and stuff better to the body. So it might have wide uses away from this. I want to also promote that as something for like heart condition stuff. And then these air tubes though, we have one that pumps out air, but it pumps out air at a negative pressure. By negative pressure I mean the air in here is actually lower than the pressure that people breathe in at whatever suit they're containing. And that means if any bubbles form, they get sucked into here, and CO2 also gets sucked in, and all these other dissolved gases get sucked in, lowering the amount of dissolved gases in both the outgoing blood and the ingoing blood. And now the only thing left is oxygen is tightly bound to the blood. On the other hand, on the other one, we're pumping in air. And this air that we pump in, we're pumping it in, and that one puts in oxygen, and we have a membrane actually so that the air we're pumping in is mostly oxygen to increase the way of to increase the amount of oxygen that's actually going to the head, and so the less N2 gas, CO2 and stuff can dissolve in the blood and maybe form bubbles later on. So this oxygen can permit this membrane. That also means that in this air that we're pumping in more, CO2 and stuff can also go into this pump in, because it's also going to have to exit at a eventual point, and CO2 stuff can to increase the rate of getting rid of CO2 and other things. Now, how we move the stuff, I would suppose, is another way we can get rid of bubbles and clots and stuff and keep blood nicely flowing. And that is that we expand one of the ones, and we want to expand, let's say the bottom one expands, the top one contracts. Well, we expand half of them and we contract half of them in a specific sequence that kind of makes the whole thing spinning around in a circle if you do a center dot in the middle of the four ones. So we expand this one, contract this one, expand, contract, like the contracting ones are on the opposite way of the ones that are expanding, and so on and so on. And you can just imagine that it draws out a circle. And that circle will push, with the help of valves, will create a current that the expanding sucks in blood. When it contracts, it expels blood or air in a certain direction that's determined by one of the valves. And by getting them so they all push and pull against each other in the method, what happens is we can get them to, the contracting ones can help pull the expanding ones more apart, and vice versa. And by having it all go in a circular motion, they can build up momentum to save power and save energy and stuff like that. But also, this causes vibrations. And the vibrations in this whole system are very, very important, actually. So what the vibrations do is the vibrations will help get rid of gas bubbles even more and help promote more easy flow and less clotting that's dangerous. It also, vibrations more easily get oxygen into the system by disrupting surface tension. Now at both ends there's a bunch of valves, including air valves, and the air valves can be not only one way directional, control the direction of the airflow, but they're also made so that they can control the pressure the air is coming in. The reason why you want to also control the pressure the air is coming in is because by controlling the pressure, you can control the negative pressure suck out bubbles, or the positive pressure that's putting in air. And that allows for more precise control to prevent bubbles and stuff under different conditions. Now, the question is, how do we monitor this complex system? Well, there's a couple ways. Shining little bits of light and stuff can very easily monitor oxygen levels. Another thing is there's a bunch of minute pressure sensors and stuff that people can build to manage that. And acceleration sensors are getting smaller and smaller, especially piezo ones. To actually cause the vibrations to move this whole thing, that's more of a trick. But the reason why I don't want to use electric motors that just turn stuff with a rotary fan is because of it doesn't get the vibration and stuff I want. And the way around that is either you make a piezoelectric like elastomer, which is like a fancy plastic that has elastic property elastomer, and piezoelectric is a type of material that you put a current through and it starts vibrating or contracting or expanding. Or you make these elastomers and you add magnetic nanoparticles or metallic nanoparticles that give it contraction or expanding properties, which I think can actually be made more in the future, more, how would I say it, more efficient than the current piezo ones. Or you add a liquid into it, these are elastomers, that doesn't spill over because of coatings and stuff, that moves when you put electric current on it because it has ions in it. Or heats up and moves, or something else, or changes conformations and move. For the hookup and the surgery for all these different parts, that's where it gets really complicated and dangerous. I want to point out that. The other thing is, if you want to make this whole thing even more efficient, is instead of having 4 big tubes, you take this 4-dimensional tubes thing I said here, and you make many of them in like a grid pattern. And that gives you a higher, and that means they can support more different circular motions in it. So the whole thing is moving in more complex patterns, but there's like big circles and moves in little circles. And that way, if there's any movement, some of the circles don't get disrupted as much. And they can, and more of the movement actually might power it. Also, there's more surface area, and more surface area means that gases and stuff can be absorbed or deabsorbed more quickly. It also means that if one tube gets clogged up, it's not as bad, but that's hard to construct. Well, thank you very much for listening. Please like and subscribe. It will help the channel out. I'm trying to reach 1,000 subscribers in a year, 4,000 watch hours. It's really hard, I think I can do it. Again, thank you much. Goodbye.